Let's talk now about a brief trig review, especially some of the things that are going to be really important for you to remember as we get ready to go into AP Calculus here. When we measure angles in calculus, and really in every math class you're going to take from here on out, you're going to focus, or the angles are going to be given to you in radian measure. And that maybe goes a little bit against what you've grown up with, either in terms of measuring angles from middle school or working with angles in geometry or working with angles in physics, where you know that one full revolution of a circle is 360 degrees. Radians are measured a little bit differently, and in fact it's a little bit more mathematically mature way of thinking about angles is to think of them in terms of their radian measure. So let's talk about what 1 radian is. 1 radian is the measure of an angle whose arc length equals the radius of a circle. And so really what I should have added here, it's the measure of a central angle, and we'll talk about the arc length. So let's draw here. Let's draw a circle. And if we look at a central angle right here, an angle whose vertex is on the center. So this distance right here is the radius of the circle. It's also going to be one of the line segments that I use to form this angle. Now then, if I open this angle up here, and I'll try to demonstrate this with my pen, as I am opening this angle up, I am tracing out the circle, and I'm getting an actual arc length here. Well, when the length of the arc has the same length as the radius, that's 1 radian, and it's a little bit less than 60 degrees. So what I have here, that's r, and this distance right here, this arc length, if it is also r, then we can say that this theta right here is equal to 1 radian. Another way to think of angle measure in terms of radians is if I were to draw any angle, not just this angle that has 1 radian specifically, its measure in terms of radians is always the arc length divided by the radius. And it just so happens if the arc length is the radius, that's how we get a measure of 1 radian. Now then, if I were to continue doing this, obviously if I did the entire circle, I would get the circumference of the circle, which is 2 pi r. And as I said earlier, if I divide that by the radius, I get 2 pi, which is 1 revolution, 1 circular revolution of an angle in radian measure. So I can say there are 2 pi radians in a circle. And I make that claim very similarly to how you would make the claim that there's 360 degrees in a circle. So I can say 2 pi radians, which I'll abbreviate RAD, is equal to 360 degrees. And if you simply take that equation, divide the 2 out, you can also say that pi radians is equal to 180 degrees. And this statement right here that pi radians is equal to 180 degrees is what we'll use to convert if we need to convert an angle from degrees to radians. You learn in conversions in science that all you have to do is multiply by this conversion. It'll change the units for you, and it'll now be in that new particular unit. So for example, I know that if I have 60 degrees and I want to convert it into radians, I can use this conversion factor of pi radians and 180 degrees. I'll put degrees in the denominator, and I'll put pi radians in the numerator. Degrees don't so much cancel. Angle measure, the units are kind of odd, and they're not the same way that, for example, centimeters is a definite measure of length, but I can kind of think of it in the sense that the degrees will cancel, and I know that 60 goes into 180 exactly 3 times, and so what I'm left with is I'm left with pi over 3 radians. Another example, if I take 135 degrees as an angle, I can multiply it by pi radians over 180 degrees. Again, we can think of it in terms of degrees cancel here. 135 and 180 both have a common factor of 45. In fact, 45 goes into 135 3 times, so I'm left with 3 pi over 45 goes into 180 4 times, and so that is 3 pi over 4 radians. In the sense of a calculus class, you really need to be able to understand an angle in terms of radian measure and have a pretty good idea of what type of angle that we're looking at. So understand that in your math career moving forward, you're going to be looking at angles in terms of radians rather than in terms of degrees. So it's important that you know how to convert from degrees into radians.